In this video, we're going to examine the Taylor polynomials for f of x equals 1 over 1 minus x, centered about 0, to see if we can come up with a general formula. So if we don't know the general formula offhand, first thing we have to do is start calculating derivatives and see what they are evaluated at 0. For instance, we start with f of 0. F of 0 is 1 over 1 minus 0, or 1. Next thing we need is f prime of x. So we're going to take the derivative of this, and a couple ways we can look at it. One, we might want to rewrite f of x as 1 minus x to the negative 1. It'll make the derivatives a little bit quicker. So f prime of x equals negative 1 minus x to the negative 2. This is going to be a chain rule times a negative 1. So those negatives will cancel, and we get 1 over 1 minus x, the quantity squared. Evaluating that at 0, so f prime of 0, it's 1 over 1, or 1. Need the second derivative. These negatives will cancel out. This is 1 minus x to the negative 2. So negative 2 times 1 minus x to the negative 3. Once again, times a negative 1. If we want, we could rewrite it this way. That'll become positive. We'll get 2 over 1 minus x cubed. F double prime of 0 equals 2, because we're going to be dividing by 1. Now with these, you just need to go far enough until you see a pattern, if there is one. Remember, these negatives canceled, so that negative coming down makes a negative 6 times 1 minus x to the negative 4, again times negative 1. So we end up with 6 over 1 minus x to the 4th. F triple prime at 0 is 6. Let's do one more, but you can start to see what's happening, and we're going to multiply by 4. Next time we're going to multiply by 5. So the fourth derivative at x is going to be, now remember these negatives canceled, so a negative 24 times 1 minus x to the negative 5 times negative 1. So we get 24 over 1 minus x to the 5th. So the fourth derivative at 0 is 24. Now something interesting about these numbers, 2 is 2 factorial, 6 is 3 factorial, 24 is 4 factorial. So notice it's the same derivative that we're looking for. So if we wanted to say, come up with a formula for the nth derivative at x, on top, if you notice what's happening, the fourth derivative was the fourth factorial, so n factorial over 1 minus x, and this was always 1 more, so n plus 1. So that generalizes to find any derivative that we need to find in this Taylor series. Now we can start to write out what our Taylor series looks like. We've got the first few terms, and so let's see what this is going to look like. So we're going to start with f of 0, which is 1, plus now f prime of 0, so that's going to be 1 times x to the first. All the terms will be positive. Now we have 2 factorial times x squared over 2 factorial. So these are my coefficients that I'm writing out front. These are the terms from the Taylor series. 1 over 1 factorial we could write in there. Plus 3 factorial x cubed over 3 factorial. Next term will be plus 4 factorial x to the 4th over 4 factorial. We're probably far enough for you to see the pattern, because look at all these factorials are going to cancel, and really what we're going to get is 1 plus x squared plus x cubed, so on and so forth. So now we can write this up as a Taylor series. So I equals, and let's think about what we want. We want to start at 1. So for instance, if I do this, x to the n, then I'm going to put my lower limit at 0, because 0 will give me that first term, 1 will give me this term, 2 will give me this term, and this is going to go up to whatever we need it to. Oops, sorry, there should be an I there, because we want to write it of nth order. And there we have our Taylor polynomial written up as a series. We can let n go to infinity and turn this into a Taylor series.